Hello friends, let us discuss a problem based on kinematics in this video. So in the question it is given that a particle is uniformly accelerated from A to B separated by a distance of 192 meters and is then uniformly retarded from B to C. The distance between these 2 points is given to be 60 meters. The speed of particle at positions A and B are given as 4 and V meter per second respectively, and the particle finally comes to rest at point C. So initially we have to find the time taken by the particle to move from A to B and from B to C in terms of the value V only. So I have drawn the particular scenario, all the values that are given the particular scenario for ready reference. So particle initially starts from point A with initial velocity of 4 meter per second and then accelerates uniformly till point B where it attains the velocity of V. These 2 points are separated by 192 meters and the particle now starts decelerating and comes to rest at point C after traveling a further distance of 60 meters. Now since the value of acceleration from A to B and retardation from B to C are given constant, and we know that for a uniformly accelerated or retarded motion, the displacement of the particle between 2 points can be written as the sum of initial and final velocity into time divided by 2. So with the help of this expression, we can easily solve to find the time taken to travel from A to B. Let us assume the time taken to travel from A to B is t1 and from B to C is t2. So from A to B I can write the value of displacement. The displacement from A to B is 192 meters is equals to the sum of initial and final velocity divided by 2 into t1. From here we can write the value of t1 to be equal to 384 divided by 4 plus v. Let us now shift our focus on the motion of particle from B to C. In the similar fashion, we can write the total displacement from B to C is the sum of initial and final velocity divided by 2 into t2. So the value of t2 comes out to be equal to 120 by v. Now in the next part it is given that the particle takes a total time of 22 seconds and we have to find the value of v. So from here we can write the value of t1 plus t2 is equals to 22 seconds. That is 384 by 4 plus v and 120 by v is equals to 22. Now from this expression we can solve to find the value of v, which comes out to be equal to 20. Now substituting this value of v for expression of t1 and t2, we can find the value of t1, it comes out to be equal to 16 seconds, while the value of t2, it comes out to be equal to 6 seconds. Now let us find the acceleration of the particle for its motion from A to B. The acceleration of the particle from A to B can be written as change in velocity upon time taken. The initial velocity of the particle at A was 4 and the velocity of particle at point B is 20 that we have just found out in our previous calculations. The whole divided by the time taken to travel from A to B. This acceleration comes out to be equal to 1. So we can say that the acceleration of particle from A to B is equals to 1 meter per second square. Similarly, the value of acceleration from B to C is equals to the difference between final and initial velocity divided by the time taken. Since the particle finally comes to rest and was initially having velocity 20 meter per second, if we consider the motion from B to C, we can write the change in velocity is equals to minus 20 and time taken is 6. Thereby the acceleration of the particle from B to C is equals to minus 10 by 3.